Today's lesson is the idea of equating annuities, and you can use this for a car problem which we're about to work on, but you could also use it for tuition problems, house problems, retirement problems, and a whole variety of daily financial decisions that you might make in life. Now, the key thing we're going to do here today is we're going to pick a key point in the life of the decision you have to make. So it could be the day you buy the car, or it could be the day that your child enters college, or it could be the day that you purchase a house. That's going to determine how we solve the problem. And basically we're going to set one side of our problem equal to the other, and it's all centered on that key point in time. Let's look at how we do this. So here's our goals for the unit. And, this is sort of an advanced topic, but it's critical for understanding introductory finance. Now, the idea of equating an annuity is whenever I move cash to the same time, or same time period, or same year, month, or wherever I'm moving the cash to, I can do operations with the numbers. I can add them, I can subtract them, I can set them equal to each other, I could multiply them. But the key is moving all the cash flows to the same point in time. All right, hit pause for a moment and read through this example. All right, this is our standard car buying problem. And if you think about when you go to buy a car, most folks usually have two things going on. First, they try to save money for the day they purchase a car. Now, they might invest the money, or they might just put it in a savings account. But either way, they're building up money for a future purchase. Now, the key word there is future. So if you think about it, we're trying to save a future value. And this will be our down payment the day we buy the car. So whenever we look at one of these problems, the savings part of the problem is solving for a future value. Now, also on the day you buy the car, you typically take out some sort of car loan if you don't pay for the whole car at once. And a car loan just sets up a series of payments that you'll pay back to the bank or whoever finances the purchase of the car. But here's our key rule, and this will come up in multiple units, and it's already come up a few times. The balance of a loan is always the present value of the remaining payments. So let's say that one more time. The balance of the loan is always the present value of the remaining payments. So the day I buy the car, the balance or loan value that they pay me is just the present value of all the payments that I will make. So let's put this together. If I go to the car dealer, I really have two things going on. One, I am saving for a future value. That's my down payment. That's the future value of my savings. Two, I'm taking out a car loan, and that will just be the present value of my loan payments. So the cost or value of the car is just the sum of these two values. So let's solve our example. First, let's start with the savings. The problem says that we have 4 years and we're going to make quarterly investments in our account of $800. So if I know that my payment is a quarterly payment, I know right away that I need a quarterly interest rate, and I need to know the number of quarters that I contribute. So we need an R prime and a T prime. To get R prime, we take the APR rate and divide by M, which is 4 here. So 14% divided by 4, which gives us 3.5% per quarter. For T prime, we take the number of years, which is 4, and multiply by 4 quarters in a year to give us a total of 16 quarters to invest. We apply the future value of the annuity formula. Here, you see the payment is $800 divided by the quarterly interest rate, which is R prime, of 0.035. Remember, when we do this by hand, we write our percentages or interest rates as decimals. We have 16 quarters, so you see the second term there is 1.035 raised to the 16th. In the financial calculator, we would put N as 16, I is 3.5, remember that's our R prime, present value 0, payment negative 800, and we compute the future value. And we get $16,766.82. Notice we put a negative on the 800 because that's money or cash flow that is leaving my pocket. Now we look at the loan. Well, we know the loan is 60 months. And our APR interest rate is 12%. So if we're making a monthly loan payment, we're simply just going to divide that rate by 12 and we go 12% divided by 12, and we get 1% per month. So now we find the present value of the loan. The car dealer has set us up with $385 per month, so that's my annuity payment, and we use the present value of the annuity formula shown below. Now a key point to remember here is if you're confused on whether to use present value or future value, just always ask yourself, which way is the cash moving? If it's moving into the future when I'm going to pull it out of the account, such as our down payment, that's a future value. If I'm going to take some value today and just pay it off, but we're trying to value it today, anytime you hear the word today, think present value. So we solve for the present value of the loan in our calculator. N is 60. I is 1, payment's negative 385, it's negative once again because it's leaving our pocket. And we compute the present value and get $17,307.69. I've also shown you the Excel formula if you want to go a little beyond our basic class here. So now we know the value of our down payment and we know the value of our loan. All we have to do is add the two values together, and we can go to the car dealer and buy a car worth $34,074.51. Not sure what that buys you in today's market, but it's a lot more than I could buy when I was 22.